Hello everyone, in this video we will look into InstaMAT, a very powerful tool for texturing. We will be covering how to get InstaMAT, go through the user interface, create a simple stylized style material, export the textures and preview them in Blender. So let's get started. Go to Google and type InstaMAT. Open the first link here, instamaterial.com. You can check out the website for more information and documentation. You can use InstaMAT for layer-based texturing similar to Substance Painter. However, in this video, we will be focusing on the element graph to create our material, which is similar to Substance Designer. On the top right, hit the Get It for Free button, and you will be directed to the licensing page. Here you have a bunch of different licenses. You can get the Pioneer license, which is completely free for commercial use, as long as your revenue is under 100K and you give attribution to the software. You can hit Get InstaMAT now. You'll need to create an account with Abstract ID and you can install the software. When you first open up InstaMAT, you will be prompted with this window. In the middle, you will find your previously open projects. On the left, you have the option for creating a new project or opening an existing one. So let's create a new project. We have different types of projects. You can create the layering project, which you can use to bake and texture assets. You have the materialize, which can be used to take a photograph and convert it into a PBR texture. Then we have the element graph, which we will be using. So let's open that up. You have different templates available, but for now, let's create the project without any template. All right, now you have your element graph opened up. Let's explore the UI and create a simple stylized style material. In the middle, you have your element graph that you will populate with different nodes to create your materials. On the bottom right, you have the navigation panel that you can use once you have your nodes on the graph. Next, on the left, you have the package management panel. In InstaMAT, you save the file onto your hard disk as a package file, and inside that, you can create different projects like the element graph or the layering project. Essentially, you can think of a package as a container. Let's rename the package. Let's save the package by going to File, Save Package, go to the location you want to save it to, give it a name and save it. The file will be saved as a .imp file. Now, under the package, you have your projects. You can create a new project by going to File, New Project. Since we already created an element graph, let's close this, rename the project, and save it with Ctrl S or go to File, Save Project. Now, let's look at the panels on the left. First, you have your material library. You will find all your nodes you can use. They're organized into categories. You can also search specific nodes by searching the name on the top here, and you can find them. The other way to add them is by right-clicking on the graph and search with the quick search menu. You click on the node and you will have an image and a brief description on the right. Let's search for material make. You can double-click it to add it onto the graph. For navigation, you can use the scroll wheel to zoom, left-click to pan the graph. You can select a node and move it around. As we saw, here is a navigation bar. You can move around, or you can drag your mouse to frame the nodes in the view. On the left, second panel is the package management, which we already checked out. Next, we have the viewport settings, which we will come back to once we create the material. You can control the viewport preview settings here, like displacement factor, tessellation level, UV tiling, etc. The fourth and the fifth panel is the 3D viewport and the image viewer combined. In order to preview the material, you right-click on the material node and hit Preview as 3D Material. Navigation of the 3D viewport is similar to Maya and Substance Painter. You can use Alt left-click for orbiting the viewport, Alt right-click to zoom, and Alt middle-click to pan. You can also use Shift right-click to rotate the lighting. On the bottom, you have the image viewer. Let's go ahead and add a simple shape. Go to the material library, patterns, and under shape, you can pick any. Let's add a box for now. Open the image viewer again. Now, to view the image, right-click on the node, view image output, or use the hotkey V. Right now, the background is transparent. Let's change it from RGBA to grayscale. Now, the whole process of creating a material will be to use these grayscale images to create a height map, and that from that, you will derive other maps such as normal, ambient occlusion, and color. Let's plug it into the height channel of the material make. You can see the bump from the square we connected, but there is no light information. So let's add the normal map to add the light bounce information. Right click and search height to normal. Let's connect the shape output to height to normal and the output to the normal node of the material make. Alright, you can properly see the bump now. Let's also add the ambient occlusion node. But instead of right click, you can just drag the output to add the node. This way, it is more aware of what nodes can be connected to the output and only shows those nodes. So let's add the height to ambient occlusion node and connect it. You can see the difference. In order to disconnect the node, you can just click on the connection and hit delete. Now you can view the image. You can also view the image by left clicking on the output of any node, which is much faster. So instead of the box, we will be creating height information for our tiles. Before that, let's add a readout node. So drag it out and type readout. It's just an empty node that relays data. Instead of connecting the outputs to individual inputs, you can drag out all the outputs by Control left click and connect them to the reroute node. Now you can simply switch by adding a new node and connecting it to the reroute. Let's delete these shapes as we don't need them. Let's change the base color. You can tinker with the other values like roughness, for which we will create a map later. So let's create our tile material. Under patterns, you have a bunch of different generators. Let's add the brick generator. You can see the tiled cubes. Let's connect it to the reroute node. Select the generator, and on the right, you have the properties for the node. Let's change the count. You can play around with the type of pattern. I'm going to choose herringbone. Let's reduce the bevel. Change the roundness. If you want to reset a value, you can just reset the arrow next to it. Now that we have a basic tiling texture, we can add elements like cracks and dents after this by using a blend node. You can search for the node, or to add the node into the flow, you can select the node connection, right-click on the wire, and add the node. Let's change it to the background. By default, InstaMAT uses its logo. We will be replacing this with the different effects for the foreground. Let's add a slope warp node. We can drive the height using a Perlin noise. Change the scale of the Perlin noise. Now connect the warp to the foreground. Let's change the blend mode to multiply. Reduce the opacity. In the slope warp node, you can play around with the intensity. Now we have chipped edges everywhere. So let's limit that by adding another Perlin noise and connecting it to the opacity mask of the blend node. I'm going to reduce the scale and increase the gamma value. Now you can play around with these nodes to get the look that you want. You can shift and left click and drag to select multiple nodes and move them around. Next, let's add some large damage. Add another blend node. In our library, under noises, we have cellular noise. Let's connect it to the output. We'll use another slow blur. Let's use another Perlin noise as well. Increase the scale a bit and connect it to the foreground. Let's change the mode to subtract and reduce the opacity. You can change the scale of the cracks with the scale in the cellular noise. Now, let's add small dents. Add another blend node. We will use a tile scatter node. Let's use some dents. Search for dents. I'm using this dent symbol. Connect it to the scatter, and let's play with the parameters in the scatter node. Let's add some variation to the size. You can change the X and Y scale. In order to scale it proportionally, you can use this lock. Now the values will change equally. Under the mask, let's reduce density. Now increase the count. Let's also add some luminance variance so the dents will have different depth. You can change the offset variance as well. Finally, let's change the seed till we get something that we like. Let's connect this to the foreground. Change it to subtract. And reduce the opacity. Okay, this looks good. This is all we're going to do for the height. Before we move on, let's look at organizing nodes by framing them. Select the group of nodes by Shift and dragging your mouse over them. Right-click on a node and hit Comment or Shift-C. You can move the frame around and change the name. I'm gonna quickly organize the remaining nodes. Now that we have the height map created, let's work on the base color. Let's use a height to curvature node. We can now use a gradient map with this. You can see that it's black and white. So let's turn off grayscale so we can work with RGB values. Let's play around with the colors till we find something good. Okay, generally it's a good practice to use a auto levels node after a curvature node to get the full range of values for the gradient map. The auto levels will map the range of values from completely black to completely white, similar to a map range node in Blender. Okay, now I'm gonna play around with the colors till I get something that I like. Okay, this seems fine. Let's connect it to the base color. Now I want to use all these height maps that we created as a mask to add color variation. Let's add another blend node. Take the output of the cellular noise and connect it to the opacity mask. Add a solid color node and connect it to the foreground. Before we make any changes, let's organize it a bit better. Instead of adding a reroute node, you can double click on the connection to add a dot point that you can move around to clean up the graph. Note that this is not relaying the data like the reroute node, so you can't create multiple connection, but it's just a way to visually organize the graph. I'm gonna change the color for the solid color and change the blend mode to multiply and reduce the opacity. Okay, I want to do the same thing for the dents. In order to duplicate these nodes, you can select them, Alt left click and drag it out to duplicate them. It will pull the connections. Connect this to the background. We can connect the tile scatter node to the opacity mask for the new blend node. Okay, let's connect it to the base color. Now we have control over the dents. I will choose a brownish color. Change the blend mode to soft light and change the opacity. Next, I want to add some random variation to the color. For that, let's add another blend node. For the noise, let's use a clouds noise. Connect it to the opacity mask. Let's play around with the color. You can change the scale in the clouds noise. You can play around with the seed. Let's change blend mode to multiply and reduce the opacity. Okay, I'm satisfied with the material so far. So let's just leave it at that. I will organize the nodes. Now that we have the material, let's explore some 3D viewport options. In order to preview how the material is styling, you can hit this option for the UV scale or click on the viewport and use the hotkey T. You can use this option or hit Ctrl T to select different preview meshes like the cylinder or a plane. You also have the option to pick between different HDRI backgrounds with Ctrl B. Again, use Shift right click to rotate the lighting. You have the option to toggle the environment. You have a couple other options you can test out, but those are the main ones we will be using most of the time. Let's further explore the viewport settings. Since it's annoying to switch between the two panels to view all the changes, what we can do is to move the viewport and the image viewer to the right. Hit the move to right option over here. You can switch between the two panels. Let's change the preview back to the bevel cube. Now, in the viewport settings, under camera settings, you have a couple of options like exposure, hue, saturation, lightness, and contrast that you can play around with. Under environment settings, you can change the HDRI from here as well. You have background opacity, blur, and rotation. Let's look at the render settings. These are more important ones. Now, if you're using a mesh like a cylinder or a plane, you can toggle the backface visibility. You have the ambient occlusion intensity driven by the height to ambient occlusion node. You have the mesh UV scale, same as the option we saw earlier, but with finer control over the tiling. You have different displacement modes. Tessellation, which pushes out the physical geometry. You have parallax occlusion mapping, which simulates the depth without any physical changes to the polygons. Okay, displacement factor. Let's say you want to preview the material with a stronger height value. This works as a multiplier to your height map. You can increase the value up to 10 and the geometry gets pushed out further. You have the tessellation level, which is basically the subdivision level of the mesh. If you have it at 1, you can barely see any displacement details. Let's increase the displacement factor to view it better. You can see as you increase it, at a low value you have a lot of distortion and jagged look as there isn't enough geometry. As you increase the value, the details get crisp. Let's leave it at default. Those are all the settings that you will need to worry about for now. Let's put the viewport back to the left. Alright, with that done, let's look at exporting our textures. In the material make, you have all these different outputs that you can export. You can also export the individual nodes as custom textures. But for now, let's just look at the material make outputs. You can right click on any of your nodes and you have this option to expose the output parameters. In this pop-up window, you can expose all your texture maps. Let's do the base color, the normal, the roughness. We do not have any metalness for this texture. Let's do the ambient occlusion and height. Hit the expose option and you have all your textures exposed. I'm just going to lay them out real quick. In order to expose our texture maps, you can go to File, Export Image and Data Outputs. Alternatively, you can use this icon over here or the hotkey Control O. On the left, you have all the output parameters that you exposed. On the right, you have the texture maps that we are going to export from InstaMAT. For now, I'm just going to delete these and we'll create new ones. Now, for the base color, hit Add Custom Output and RGBA option. To assign the base color from output templates, drag it on to our unassigned custom output template. Select Map to RGB. I'm going to do the same for the normal map. Since the roughness, ambient occlusion, and height maps are all grayscale, I'm going to choose the option to create a grayscale output template. Let's create 3. Let's drag our roughness, ambient occlusion, and height output templates onto them. Okay, now that you have the output templates, you can check the textures that you're exporting on the left. We can rename the texture names. I'm just gonna type in base COL for the base color. You have the output settings. You can select the output path for your textures. Okay, let's rename our textures. The output name in the curly brackets will basically be replaced with our texture map names, like the base COL or normal or roughness. You have some other data information that you can add as suffixes. You can change the file format for the output image. I'm just going to leave it at PNG. You can choose the bit depth for the image. You can go ahead and export the textures. Before that, I want to show you how to export any of the other nodes as a custom output so that you can use different maps for more control on your materials. Let's say you want to export this cellular noise output as a custom texture. Right click the node you want and hit expose output parameters. Toggle it and give it a name. Now you can access this expose parameter in your export window. We won't have it in our output templates. Let's create a new grayscale output. Leave it at default and type the name. Make sure the name is same as this. Create a new output template and drag it into that. Now we have the cell noise. Let's export the textures. Okay, we have all the image files in the location. As we can see, the roughness texture is empty. Let's quickly create a roughness map. For this, I will connect the height output to a levels node. I want the crevices to be rough. So let's invert the values on the levels. Since it's too extreme, we can reduce the range of the black and white values. Now, for some variation, let's use a blend node and add a cloud noise for the foreground. Change it to multiply and reduce the opacity. Let's connect it to a roughness channel. Group these nodes. Let's go ahead and export these again. Now that we have all the texture maps, including the cellular noise, let's hop on Blender to test out the material. I'm going to be brief as this is not a Blender tutorial. Let's add a plane. In the shading tab, create a new material. Make sure you have the Node Wrangler add-on. Select the Principled BSDF, Ctrl-Shift-T, and add the image textures. For the ambient occlusion, let's blend these with Ctrl-Shift right-click and you will get a mixed color node. Change it to multiply. Flip the sockets. Now for the displacement, open the N panel with N. Under Options, Displacement, change it to Displacement and Bump. Subdivide the mesh a couple of times. Reduce the displacement value. Let's add a value node to the scale to control the tiling. You will have to change the displacement value now. Go to render mode. Let's add a sunlight. Right click the mesh and hit shade smooth. Alright, that will be all for this material. You can go back to InstaMAT and play around with the values to create some variations for this texture. If you have any questions, feel free to ask in the comment section and I will try my best to help you. I will be making more tutorials on InstaMAT, mainly to create materials in the element graph. So you can subscribe to the channel and hit the bell thingy to stay updated with new videos. Hope the video was helpful and thank you for watching.